Hello, everyone. So, today we're going to see a realistic demo of chaining vulnerabilities by bad actors to compromise accounts and systems. So, most of the time in a realistic world, um, uh, when a company gets exploited, uh, they might not have the bad actors might not have one vulnerability that they used. They usually have one or two vulnerabilities, and the company probably thought, like it's a medium severity vulnerability, is not gonna be exploited by itself. But the bad actors would find one, let's say critical or high vulnerability, another medium severity vulnerability. They combine those two vulnerabilities together and have uh, a major effect, an easier way to exfiltrate data or carry out some kind of attack. So today what we're going to see is we're going to take a realistic case of, let's say, uh, we use the same PinewoodStore application that we used, and in this case it's just going to be PinewoodStore Auto Shop Lab, and we will see a case of where a site has request smuggling and reflected XSS vulnerability. So with that being said, I actually created the lab entirely in Docker. So what I'm going to do at the end of this video, I'll probably make this public. So if anybody want to practice, go back and rip the contents and maybe create the lab in Docker and try to practice this. They can do that. So currently it is still private, but I'll make it public at the end of this video. So. All right, with that being said, let's go ahead and get started. So I'm gonna go ahead and clone the repo. I usually try to do this here, so let me let me do it here today. Inside demo. I already have, as you can see, my Docker desktop is open. I don't have any Docker containers right now, so first let me clone the repo. All right. All right, we're gonna use the Docker command Docker compose. All right, so site is up. So if I open up Docker right now, as you can see here, I'm gonna go over the site. It's actually I try to make it as realistic as possible most of the time when I create the site. I even try to make the UI better. That way, it'll be more attractive and won't be like some boring site only has some front end. From a functionality wise, I mean, you can go. So yeah. It's I try to make it, like I said, a very realistic site. This is what the site looks like. It does have services, as you can see, and specials, about section, testimonials, contact, and schedule now, and also has login and also registration. Now, this site uses in the backend MySQL database, so you can actually, the way you would do it is you would go ahead and register an account, two accounts, and we try to exploit the two vulnerabilities. For this demo, what we're going to do, we're going to try to see if we can combine two vulnerabilities, well-known vulnerabilities. One is reflected XSS. The second one is request smuggling. Now, the request smuggling part is the one where a lot of people have a problem of grasping the concepts. So I'll focus more on that But the XSS, in my opinion, honestly, if you're in cybersecurity, a lot of people understand it. And I also have a video details on that. Uh, Whether you like try to understand the reflected XSS or stored XSS. I already have a video on that, so I'm not gonna go too much into it. But yeah, I'll focus on the request smuggling part. That way it will be easier. And I'll go a little bit deeper on that concept. That way you would understand. Because a lot of the videos that I see, most of the time when people try to explain request smuggling, they go straight to uh, exploiting the vulnerability. They just copy a payload and just start exploiting it without explaining why that is a payload or something. But in my opinion, if we can understand better on how uh, a transfer encoding chunk works, that would that would make it a lot easier. Let's say if you have a practical, maybe a production site that you or probably this is not recommended to test on a production site, but any pen testing, let's say a requirement by the client, you need to test if it does have vulnerabilities with regards to request smuggling, then it will be a lot easier for you to modify the existing payload and try to test it. Because um, it won't be advisable just to kind of copy some kind of payload from somewhere and just try to push it, right? You might end up taking the server down, and also you might not understand what was going on. So I feel like it would be people could benefit a whole lot better if they understand how transfer encoding works. With that being said, let's go ahead and get started. So this is what the application looks like. I'm gonna go ahead and start with the reflected XSS. The reflected XSS exists on this page. Let's say, let me show you. Let me demo this on here. Put a message. Our usual alert XSS. All right, let's see. Submit it. I think I might have. Yeah, actually used double on one side. So, yeah, so as you can see here, it does have reflected XSS. Now, the reason why it would be best to combine it with something else is because, honestly, as you know, reflected XSS, the way it works is an attacker would send the victim a link that has a payload, and when a when the victim clicks on it, it would execute a JavaScript within the context of the browser that has a cookie or redirect him to another site or a malicious site. But basically, the concept is uh, the victim has to be convinced enough to click on a link, since this is actually reflected XSS. It relies on tricking the victim somehow, whether using social engineering or maybe sending some kind of phishing email. So, really, it's not the most effective way for an attacker to exploit the vulnerability. So, if you can find a second vulnerability that you can actually combine it with, then it would be a most effective way. So that's how most of the time real hackers would do it. They would combine multiple vulnerabilities into one and try to make it easier to exploit. So yeah, this is the first one, and now that we know how we can exploit it, and also I just want to show you something. Uh, so let's go ahead and start registering an account, a test account that we can use. So let me John Doe. Yeah, I try to make it more realistic for auto shop. So let's just, basically saying it's because I created the password is very common. That's the browser warning me it's not a strong password. So yeah, we created the first one, John Doe at Pinewood.com. So we can use that. And the second one is use. All right. So the second one is complete also. So now what we need to do is first off, let's go back here. A couple of things I want to show you. I'm gonna log in with currently I don't have any authenticated cookie, so it's not gonna be important. I only have session ID. So log in for a hacker to actually exploit a vulnerability and log into a person's account, they would need not just the session ID because the session ID is gets created when you hit the any page, but you need uh, uh, authenticated part of the auth underscore key that is actually required to from the hacker's perspective. But let me go ahead and show you what that I mean by that. So if I were to log in using one of the accounts that now I'm logged in, it's showing as my account, welcome John Doe. And if I were to go to inspect application, as you can see, auth token is created in addition to that. So you're gonna need both. Uh, and for demonstration purposes now, like I've explained it multiple times, when it comes to XSS, most modern sites nowadays are securing any kind of authentication cookies using the HTTP only settings. What that means is a JavaScript would not be able to read the value of the cookie if HTTP only is enabled. But for demonstration purposes I turned it off so we can see how hackers actually exploit this vulnerability and uh, do session hijacking, take over an account by reading the cookie. So using a JavaScript and XSS. So we logged into this account. Um, the first thing I'm going to do is actually I'm going to go ahead and open up another browser. In this case, all right. So now let's go ahead and look at the second vulnerability, which is part of uh, the chain of vulnerabilities. So before we go to the request smuggling part, also let's make sure that the XSS we can read a cookie by exploiting XSS. So I'm gonna go ahead and try to do it right now. So just put James and I'll use our usual document.cookie JavaScript. Yeah, as you can see, it can read. Now this browser doesn't have a cookie yet, so let me go ahead. The second, the auth underscore token cookie, which is required to take over an account. So as a matter of fact, what I'm going to do is let me log in. Alright, it's logged in right now. I come to John Doe, and if I would go back to contacts, so now when this executes, it should read both cookies. So, and as you can see here, we have two cookies, the auth token cookie because I logged in, and the session ID. Alright, so the next thing is also check to see if we can actually send this cookie over to an attacker controlled site. So in this case, we're just going to use the public webhook site, right? So uh, in a situation like that, what an attacker would do is actually they would use the fetch API and try to send the cookie over to an attacker controlled site. In our case, we're just going to go ahead and use a webhook site. So I'm going to go ahead. As a matter of fact, let me open it on another browser. That way it'll be more realistic. Okay, this is another browser, so webhook sites. This is from previous ones. This is a public site that you could use for a test like this. So I'm gonna copy this URL and I'm gonna use a fetch API. The basic construct is like something like this. Execute the fetch API JavaScript, and inside of it, it would have a URL and different parameters inside parentheses. So let's paste here. These are the parameters that are like basically it's talking about what kind of request is going to be. So to do the fetch API, send the API over to another site, you use a post request, and also you need to specify no need to use course configurations. So you're going to use what's called mode, put no course. And finally, the most important part, obviously, the body needs to carry the cookie. So you can use body and document that cookie, which is the same thing that we used on alert. So when I send this, instead of reflecting on the browser, what it is going to do is going to send over, it's going to read the cookie, send it over to the remote site. In our case, it's just going to be the webhook site. As you can see, I got a notification from the other browser basically saying it received some kind of information. So let's go check it out. So as you can see here, it read the cookie, send it over to a remote site. So this is what we're going to do. And the reason why I run it right now is because as I'm completing this, actually, it creates the URL for me here. This is something I'm gonna use next when I'm trying to combine it with the request smuggling. So let me copy this and put it as a note. I have my notes editor here. Because it's already the site already URL encodes it for you. So Yeah, let's save this because I'm going to use this in the future. All right, so now let's go ahead and get started on request smuggling. All right, so now let's talk about request smuggling. So request smuggling is a kind of vulnerability that happens when there's inconsistency in parsing techniques by the front end and the back end servers. Specifically in this lab, what we're going to look at is the front end would use the content links header to determine where a request ends and another request begins, while the back end uses what's called transfer encoding or chunk header to determine where a request ends and another request uh, begins. Now, anytime there is actually inconsistencies like this between the backend and the front end server, it would allow an attacker to smuggle a hidden HTTP request in the body of another in the body of a request, and let's say a post request, and bypass maybe if there is some kind of a firewall on the front end, it can bypass it by hiding it in front of the first request because since the first request only sees content length and not transfer encoding, it's going to think there's only one request. By that, what I mean is let's go over and take a look at this request. If you take a look at this request, it has two headers. Now, the front end understands only content length, so it's gonna assume everything is actually one request, and this zero and get are part of the body of the first request. Now, on the other hand, the backend it prioritizes over content length. If it sees both content length and transfer encoding, it prioritizes to the transfer encoding header. So we see that it would actually treat this as a transfer encoding or transmission. Now, in that case, what it's going to see is it's going to see two requests, one post request like this one, and another get request. So by doing so, the attacker just smuggled a get request inside of a post request, and that is actually, you can think of it this way. Now, to better understand how uh, uh, a bad actor would actually design or craft a request, we need to understand how transfer encoding chunked works. So to do that, let's go ahead and look at the schematics. Now, for assumption purposes, let's assume this is not the case, but let's assume just to understand how transfer encoding works. Both these servers that you see here, they are planning to communicate using transfer encoding. And this server needs to send information to the other server on the other hand using transfer encoding. Let's say it needs to send Wikipedia to the other end. What it does, the first thing is it breaks down Wikipedia into chunks of data, and you can think of these two as chunks of data. And let's assume the first one is Wiki, the second one is Pedia. Now, the first thing it needs to do is actually calculate the length of Wiki, the first chunk, and send over the other end. Let the other end know the length of the first chunk that is going to send it. And what it is going to do is, since Wiki has a length of 4 in hex, it's just going to send 4 slash carriage return in a new line and send it over to the other end. By doing so, it was letting the other end know I'll be sending you a chunk of a size 4 in X. The next thing, what it does is it would actually send the actual data after the length, in which in this case is going to be wiki, and is also going to send R and N, which is carriage return and new line. So it would do the same thing with the second chunk, which is pedia. It would actually send PEDIA actually has a length of 6 in hex, so it's going to send 6 R and N. And the next is going to see the actual data, which in this case PEDIA, IA, RNN, carriage return, and a new line. Which is with each request it sends, obviously it needs to send that because it needs to go to a new line. So now that it actually has completed sending the Wikipedia, what it does is it would send finally 0 carriage return, new line, carriage return, new line. This actually lets the other end know the transfer encoding transmission has completed. So that's how that is a technique that a bad actor would use to craft, especially crafted uh, requests. Even though the first server in our case only looks at the content length, not the transfer encoding, the backend is gonna think if it sees this data, if it sees this data, it's gonna think because it actually prioritizes over, like we talked about, the backend prioritizes transfer encoding. So it's gonna assume this server, the front end, is sending it information in a transfer encoding form. So it's gonna assume this actually as a separate request. So that's what the bad actors would use to actually craft the request. So in our case, let's go back to our request. Uh, and if you look back into repeaters, this is going to be, like I said, this is going to be treated as one request by the front end and two requests by the back end. So what could happen? Now, if I send this, let's say, if I send this G, the front end is one request, it will send it over. The back end will process everything, and if I actually select this, as you can see here, if I expand it on the right hand side, and this is 0 carriage return, new line, carriage return, new line. Like I mentioned earlier on, each time a server that prioritizes transfer encoding sees a carry 0 carriage return, new line, carriage return, new line, because 0, as you know, is actually the length of the next chunk. And by sending this, is letting it know the next chunk is not going to be is the length of 0. It means there's not going to be a chunk. The chunk is complete. So each time you see 0, RN, it means the completion of the chunk transmission. So it's gonna treat this as a new request. So what it does, since this is complete, the backend server would leave this in its response queue because the backend would have its own queue, right? It would receive multiple requests from different users, so it would have a queue. So since it doesn't know what to do with this, it would just leave it in its queue. So what happens is when the next person sends a request, the other request, if it is actually, let's say, if it's post request, it would be kind of be like this. In the queue already has G, and the new request that just came in will have post. So the new request response would be the new request would be treated as G post because G already poisoned the response queue. The backend server would treat it that way. So that's the concept of how uh, uh, the response queue is poisoned. And we're going to go ahead and take a look at it specifically using uh, a specific request. Like I said, these two servers are actually vulnerable, and we can prove that. And all right, so I'm going to go ahead and demonstrate that the front end and the back end are vulnerable to request smuggling using a Python a Python script. It's actually a few lines of code, honestly. The reason why I chose to use Python script is because you need to send first you need whenever you testing any kind of request smuggling that requires the, that requires the request to be sent on a more, I would say, faster way of you need to send it a little bit faster than how a normal BERT repeater would send it most of the time to see any kind of uh, if you need to poison the request queue. So if you if you use Python, it would actually give you an option to send raw HTTP TCP requests easily using the library requests. And you can also import the library time and set up kind of like you can add a timer where you can adjust it based on how you want to send a request. You want to send it faster, you want to send it slower. The reason is most of the time when you're testing this, there's going to be a web application firewall. If you run it faster than where it should go, it would probably be blocked, right? If I were to send this request right now, it's actually sending this request every 1 second. Let's say if I send this every zero point 0.5 seconds and it has both headers, in this case chunked and content linked, more than likely it'll probably be blocked on a web application firewall. So most of the time when you're testing stuff like this, where it requires you to send a request that has both headers, and also the request needs to be sent uh, a little bit faster than how you would normally send a request by clicking a send request, then it would be best either to use uh, Turbo Intruder extension on burp, or you can just you can use Python and create a small script like this. I would say, as you can see here, it's just only 20 lines of code. As a matter of fact, if I didn't put any of this informational, like the keyboard interrupt and all the other stuff, I might actually make it probably about uh, 10 or 11 lines of code. So it's very simple, honestly. It just sends a request repetitively. So let's go over it. So first it defines a constant, the HTTP. Then it defines the headers. Obviously, you're gonna need to send both headers, right? Content length and transfer encoding. And connection keep alive is for the backend, because if it is chunked, it needs to actually keep the connection open. And the next thing and the most important thing is the payload. Payload means basically uh, the body of the request. As you can see, data payload. And the reason why it is 0 RN slash RN, what this means is, we talked about it earlier on, is these are what's called CRLF, carriage return line feed characters. It's basically telling it go to the next line or new line. So each time when a chunk request is complete, this is what you need to send. Uh, 0, carriage return, new line, carriage return, new line. And any request after that, it would be treated as a new request. And that's how you would poison the request, because now we're going to try to poison it using D. D would be left in the request queue, and the next request that comes in would actually, at some point when it gets poisoned, let's say if the next request is get, it would be D get, as the next request is actually after the queue is poisoned. Is post is going to be D post. And also I'll talk about why specifically these letters can't be any random letters. They need to be the first letter of each of an HTTP verb. So an HTTP verb is either get, post, options, or put or delete. So any of the first letters of those HTTP verbs will work, but you can't just use any random word, or you can just use instead of the whole request. But just to check it, we can use something like that. So I'm gonna go ahead and send this. I'm gonna start this. I believe this is where I put it. This is the one. Yep. All right. This is where actually. So any of you who decide to actually test this by yourself and practice, I'll put the Python script in here and you can play around with it. But it's just sends a request multiple times. You can write it yourself. So honestly, I'm sure. So. So when the request gets poisoned, what happens is, like I said, we're using D right now, and it's gonna do D post, and that would return a 405, not allowed, method not allowed request. So, and we're gonna take a look at the server side response. As you can see here, the is already happening 405. So I'm gonna go ahead and stop it. So if you look in here on the server side, as you can see here, it was post all through, and when the poison happens, it start doing, instead of post, depost, depost, because the D got left over in the queue, and the post got appended to the D, which was the poison that was left in the request queue on the back end. So it started doing depost, depost, and since depost is actually not a defined HTTP header, it's going to return 405. Okay, so, and it's still doing D because it hasn't cleared off. It's eventually going to clear off. All right, that's about it. So the next thing is, what can we do to combine uh, this with cross-site scripting that we have? Now the cross-site scripting that we have, like I said, is just, it would require if we need to exploit it by itself, it would require that we send the payload through email or some kind of social engineering. We use social engineering and convince the victim to click on it. What we're going to do by combining these two vulnerabilities, we're going to make it in a way it acts like a stored XSS, where you don't require any user interaction, but anybody who's logged in, when the request queue gets poisoned, it would affect everybody. And this is more effective and more dangerous way of actually an attacker can actually gain multiple or compromise multiple accounts, because anybody who's actually logged in at that time, and once it's poisoned, um, he could be affected, and their account could be compromised. So the whole idea is, now that we know that it actually poisons, we can poison the request queue. So instead of D, what we're gonna do, we're gonna try to use a normal request, like a GET request. And since we determined already, if we go back and look at something we left behind, if you see here, this is this is the request for the reflecting XSS. So we can send this over, instead of sending this over the email, we can actually use this. Have the server send this for us for a user once the request gets poisoned. So instead of D, we can make this one, which is a one that has a payload, and this will be delivered when a user tries to browse to a site. Their request, instead of their request, they would actually receive the response to this payload, which in this case would execute a JavaScript in their browser and steal their cookie. So I will demonstrate it how it could be dangerous, because anybody who's logged in would be affected. Their cookies would be stolen. So what I'm going to do, I'm going to already signed up for 2 accounts, and I'm going to show you how those both accounts would be compromised. All right, so now the last part is actually combining those two vulnerabilities, so we can actually convert this uh, reflected XSS into a stored XSS. It would actually affect everybody accessing uh, the the site, and we can have multiple people would be affected, their account be compromised, their cookies would be stolen. So how do we do that? So we already determined that we can poison the queue using G. So what we're going to do is, instead of a G, we're going to make G a request. In this case, the XSS payload. So if you go back to the site and go to contact us, and let's put, and if I were to, let me add the payload again, be fetched. I believe I have, let's go ahead and close it that way. Some of the requests. So copy this. Come on. Parenthesis. Closed. Now let's go ahead and populate this. The method would be posts mode. Finally, body. Looks so. The payload should be good. If I were to send this now, I should get a response on my webhook site. So, all right. So it is working, and if I go back, this is a request, and as you can see, it install session ID and auto. So now going back to my site, if you notice, this gets reflected on the browser as well. So this is a request that I need to send to the backend. That way, the backend would respond with this request, would respond to the request as this. That way, the victim would get a response to this payload, which in that case, it would be that this payload would actually execute in their browser. Uh, the reason being is if I were to copy this, if I were to go to empty browser and actually paste it, as you can see here, still the cookies in a new tab. So I'm gonna go ahead and copy this. So this is the same thing as if I open it on the browser and actually executes it. It's the same thing as just doing a GET request, right? When you open up in a URL, you just doing a GET request to that URL. So in that case, let's go ahead and devise the payload in here. So the request that I'm going to be smuggling is going to be GET request to this URL. So I'm going to post it. Since I already have the host in here, I don't need the host, or I can just put it on the bottom. So all right. So it would be like just like the top post request. So it would need the protocol. Now, what's going to happen is when you poison the request with this request, and another request comes in, it would be actually concatenated to the end of this. But if you add a new line character to the end of this, what that means is the request that comes in would be kind of like we go to a new line. So it won't technically affect your request. So what we need to do when we actually put this on our Python request, we need to add uh, a new line character. That way the concatenated request would go to a new line and this would still execute. So let me go ahead and copy this first. I'll remove the D already. So So after this, we need to make sure we put, all right. So that way, then the post request that gets appended goes to a new line. All right. So now it is ready. Save it. Now what I have to do is actually, yeah, I need to start running it, and we start sending this request, and I'm gonna act like the victim and log into one of the accounts that we create, and I'm gonna browse through different, like access different sites, and at some point when the queue gets poisoned, it would actually execute this payload. So I'm gonna start. Now let's go back. I have this account that is logged in already, or I can just log in. As a matter of fact, I don't want it to execute right now because it's gonna affect me. So let me log in first. Think. Uh, why is it saying that? Okay, so what is, all right, we're gonna register a new account. Okay, let's register another account. All right, so now let me log in. This is the first account. Okay, it's logged in. All right, let's start. This is gonna be one account, and let me open up another one so we can see multiple users could be affected. Is this as opposed to the other one? Uh, let's use this. So I believe the one I've logged in is okay. Let's log in as David. Alright, so I'm logged in as David and Adrian. David. Now I'm gonna start the attack. So I'm gonna access like I usually access account, and you would see at some point when the poison happens, it would actually this would be redirected to okay, it happened, and you can also see it's just so. Let's do the same thing on the other one as well. This is on Adrian's. So another user would be affected just to show you. Yeah, same thing. So now, if I were to, as mission accomplished, so I can just go ahead, Control C. So everything, if I were to go to my site, let me look at the time. That's 9 minutes ago. 8. So these are the two that just happened. So I'm gonna, this one is 9 minutes ago, old ones. So I got the two cookies. What I can do in a situation like this, I'm gonna go ahead and open a new browser and show you this is actually practically the cookie being stolen. So Firefox was closed. It doesn't have any cookies or anything. So let's do localhost. It doesn't have any cookies, and I can also show you if I inspect this storage, no cookies. But let's start adding a cookie so we can actually see is a stolen cookie how it works. Just gonna go ahead and do that, and this first one. There's an easy way of doing it instead of manually doing it. The reason why I do this is actually if you add it to the browser, it can maintain it. You can also do it from burp, but from burp is actually the cookies kept uh, in burp, so you can only stay one page. But this actually you can browse to other pages and also make updates. That's the reason why I chose to do it this way. And almost. All right, now we have the cookie. I can just browse to the accounts page, and as you can see, I have access to this user, and I can actually update his profile. Just say hacked. All right, if I go to the account, you can see Adrian Chapa hacked, and I can do the same thing. I can log out, inspect, go to storage, and actually delete. I can do the same thing to the second account. All right, now let's go to, so you can see I'm on Adrian's page right now. I can update his as well. I mean, David's page. David Duke hacked. And also, I know for a fact these people are logged in still on another browser, so I believe I stopped, so it shouldn't affect me. But yeah, this is one of the pages for one of the users. So if I go to this page, it's gonna, as you can see, is his hacked. So the second one, David Duke, and the same thing. So what this shows you is actually you can combine multiple vulnerabilities, or bad actors would actually use multiple vulnerabilities escalate uh, to escalate the privilege, or get an effect that actually has a tremendous output than the individual vulnerabilities separately by itself. So now I'll be sharing the details of this lab, and also I'll share this link on my GitHub repo, and I'll make it public. That way people can rip this repo and just practice, or maybe redo it, or change it, whatever they want to do with it. But yeah, uh, since this is a Docker, yeah, they can play around with it if they want to. After they done the practice, they can just delete it. So that's all I have for today.